Hello. Hello and welcome to this video. So we will complete the documentation of Difflib and we will see several examples. So two of the examples will be, or rather several are given in the documentation itself. And I will show you one fantastic example which you don't want to miss, but that will be towards the end. So make sure that you watch the video till the end. All right. So we left here get matching blocks in the last video. So let's see what get matching block does. So it returns a list of triples describing non-overlapping matching subsequences. Each triple is of the form I, j, n means A colon, list A, I colon I plus n is equal to B, J colon J plus n. The triples are monotonically increasing in I and J. The last triple is a dummy and has the value len A, length of A, length of B, 0. It is the only triple with n is equal to 0 if I, j, n and I prime, j prime, n prime are adjacent triples in the list, and the second is not the last triple in the list, then I plus n less than I prime or j plus n less than j prime. In other words, adjacent triples always describe non-adjacent triple blocks. So the example is given here, which you can read. It's a sequence matcher object with none, abxd, abcd, and you invoke the get matching blocks to get the output. So that you can understand on your own. Then we have get opcodes. Return a list of 5 tuples describing how to turn A into B. Each tuple is of the form tag, I1, I2, J1, J2. The first tuple has I1 is equal to J1 is equal to 0. And the remaining tuples have I1 equal to the I2 from the preceding tuple. Likewise, J1 equal to the previous. The tag values are strings with these meanings. So the tag argument, or rather the tag output, which it will return, it will have replace, delete, insert, and equal. So the replace, in the case of replace, A, I1, I2 should be replaced with B, J1, J2. In case of delete, A, I1, I2 should be deleted. Note that J1 is equal to J2 in this case. For insertion, B, J1, J2 should be inserted at A, I1, I1. Note that I1 is equal to I2 in this case. And for equal, the subset sequences are equal. So let's say we have this these two strings A and B, and we invoke the sequence matcher. Then we iterate over the get opcodes and we invoke the output for these 5, and we format tag I1, I2, J1, J2 in the sequence. So see, first it says that delete Q, then A, B are equal, then replace X with Y, and then we have CD equal, and finally insert F. Next is get group opcodes and is equal to 3. Return a generator of groups with up to n lines of context, starting with the groups returned by get opcodes. This method splits out smaller change clusters and eliminates intervening ranges which have no changes. The groups are returned in the same format as get opcodes. Ratio. Return a measure of sequences similarity as a float in the range 0, 1, where T is the total number of elements in both sequences and M is the number of matches. This is 2 into M by T. Note that this is 1 if the sequences are identical and 0 if they have nothing in common. This is expensive to compute if get matching blocks or get opcodes hasn't already been called, in which case you may want to try quick ratio or real quick ratio first to get an upper bound. So we have tied and diet, and then diet and tied, and you find the ratio, it turns out to be 0.25 and 0.5. So if you actually want to see how this works, you will have to go through the source code of Python. Then we have quick ratio. So it returns the ratio quickly. Real quick ratio is very quickly. Now, the three methods that return the ratio of matching to total characters can give different values due to different level of approximation. Although quick ratio and real quick ratio are always at least as large as ratio. So see, ratio is 0.75, S quick ratio is 0.75, and real quick ratio is 1. Now we have some sequence matcher examples. So here we have two strings, private thread current thread and private volatile thread current thread, and our lambda function is empty, space. So ratio returns a float in 0, 1, measuring the similarity of the sequences. As a rule of thumb, a ratio value over 0.6 means the subsequences are close matches. So in this case, we have 0.866. And if we are interested only where sequence matches, we get matching blocks. So it tells us that A0 and B0 match for 8 elements, A8 and A17 match for 21 elements, A29 and 38 match for 0 element. Note that the last tuple returned by get matching blocks is always a dummy. So len A, len B, 0, and this is the only case in which last tuple element, number of elements matches 0. If you want to know how to change the first sequence into the second, use get opcodes. So this is the output of get opcodes. Now we have differ objects. Note that differ generated deltas make no claim to be minimal diff. To the contrary, minimal diffs are often counterintuitive because they sync up anywhere possible, sometimes accidental matches 100 pages apart. Restricting sync points to contiguous matches preserves some notion of locality at the operational cost of producing a longer diff. So we have the constructor differ of the class differ. We have line junk is equal to none and char junk is equal to none. So line junk and char junk are kind of similar, which we did in last video. So the objects are used via single method, that is compare. So it compares two sequence of lines and generate the delta a sequence of lines. Each sequence must contain individual single line strings and end with new lines. Such sequences can be obtained from the read lines method of a file like object. The delta generated also consists of new line terminated strings ready to be pinned as is via the write lines method of a file like object. So suppose we have text one which has 4 lines. So as you see, at then there is new line over here, and we split this line, these lines, and we keep the endpoints. That is the last character. So length will be obviously 4, and then we see that for the 0th element, or that is for the first line, the last character is obviously \n, and similarly for text 2. And then you instantiate differ object, and then once differ object is there, you compare them, d.compare text1, text2. Once you have done that, it will return a list, and that result, which is the list, you can do a prefix printing, and you will see that the output is, so first line is same, so beautiful is better than ugly. Then you delete the second line from first and add the third line also to be deleted, and you add the third line and you delete fourth, and then add fourth, and then add fifth. So that's how you get the patch. A single multi-line string, it looks like this. So if you print this as a single string, then you have these positional markers, which we have already studied earlier. What is the meaning of question mark, minus, plus, that we have studied. Now we will build, we have 2 examples here, quite large examples, not large, relatively large for you, because most probably you wouldn't have written large programs. So the first example is that we are going to do a command line interface to difflib.py, providing diffs in 4 formats and diff context, unified, and HTML. Okay. So you import these modules. So the key is difflib. We have not yet done argparse and all. So we first look at main. Okay. So it is an argument parser. We have not done this. So a bit difficult to explain this because we have not done that. Okay, so I'll tell you. So every command on Linux terminal takes an argument. Okay, so let me show you. Suppose you have ls, then ls minus 1 is an argument, or ls minus or switch, it is called a switch. Okay, so the switch can have some value as well. So here it adds the argument minus c, action is store value and default is false. And if you take help on that, then it produces context format diff. Similarly, u is store true and it produces unified diff. M is producing HTML diff. Can use minus C and L in conjunction. Then we have minus N, which will do N diff. And minus L is how many lines you want. Its type is integer and default is 3. So then you add argument from file and add argument to file. Okay. So as you see, these are optional stuff. Okay. But you have to supply at least one. Then you pass the arguments from the command line. Then you look at options.lines. Okay. That is, we are looking at this argument. You want to know how many lines are there. Then you want from file and to file because those are mandatory arguments, from file and to file. Then from date you find out from file, you look at modification time of the file, then at the to file you look at the modification file. Then you open both the input files from file and to file and read the lines. Okay. And once it is done, you simply call unified diff, NDiff, HTML diff, context diff and all. And then you pass the arguments. So we have already seen these functions. So you just pass those arguments. The arguments are quite similar in nature. And once they are called, you write the lines. Now file m time, if you look at what it does is that it starts the path of the file and it looks for the modification time in the stat structure or object, and the default, it converts that to time zone UTC, and then it constructs a datetime object from this input. Okay. So if you want, you can run this program and you will need to supply it 2 arguments. Let me show you how to do it. Okay. Let's say we copy this. Let's do this. You go to Python 3, sorry, videos, Python 3 programming. Okay, and we do vi difflib1.py and we paste this. Okay, and we then we say Python paste difflib.py difflib1.py, and let's say we say closure.py. Okay, and we have to supply a diff argument. Let's do an ndiff. Okay, so we do an ndiff argument. If you look at this, so ndiff argument is context unified diff and ndiff is n. So we give this. Okay, minus n it takes minus n true. Why is it saying that? Okay, let's look at this. Difflib. Okay, I got it. This should be difflib1.py and then from file to file. Unknown option. Oh, this argument is going to Python. Okay, so minus n doesn't require to be true, and there you go, you have the diff. Okay, so that's how we compute the ndiff, and then you can pass it other formats also. For example, if you want to get HTML diff, so for HTML diff we have to give m. So you get the HTML diff. If you want to see how it looks like, I can show you. I may not have Nginx running, but anyway. Let's say vi on difflib. html and you paste it. And then in the browser, you can open it. Videos, Python 3 programming, and we are looking for Difflib. So this is how it looks like. Okay. All right. So what this means is that if you want to make first file as a second file, you delete all this, whatever is in red, and then whatever is in the green, that is added. Okay. So that's the simple meaning of that. Now let's look at if example. So if the name of the step, if we put is if, then the input, how we run this is file1, file2, -q is optional, R1, R2 is optional, less than if output, greater than file1 or file2. So we redirect the output to this. Print a human-friendly file difference, report to stdout. Both inter and interline differences are noted. In the second form, recreate file1 and file2 on stdout from an if report on std. So we don't need to read help. So first we look at main, we see get opt, and it is another library. So you have two options, Q and R. And if there is an exception, so we don't care about that. Okay. We have noisy is equal to 1, qseen, rseen is equal to 1. So it looks at the options. If -q is provided, qseen is 1, noisy is 0. If -r is provided, rseen is 1, watch file is equal to value. So -r will require a value as well. Okay. Now qseen and rseen both are there, then can't specify both q and r. If rseen, then no args allowed in -r option. If which file in 1 or 2, restore which file and return 1. So this way you can run this, you can go ahead and read this. So the main thing which happens is, which happens here. Whatever file you get, it reads the contents of these files F1 and F2, opens the file and reads the line, and then perform the if and prints the line. That is the every line in the output. So I'll show you this one as well. For example, yeah, and this .py. So Python is ndif.py. If you run, it will give you an error. So then you say -q, and let's say close, let's say deco files, Python 3 programming deco1.py and Python 3 programming deco2.py. So it gives you the output, and then you have -r. Okay, so sysrv1 column can't specify both q and r. So why it says that r? It requires something else with r. Okay, we have to redirect the output. Okay, so okay, so okay, I got it what it is doing. So we have to do this, and Python is -q and if.py. So that will generate the output, and then we generate it as and if underscore output. That is the redirection. Option 3. We will have to generate the output and save it first. Okay. So you take this and you say and if output, and then you do this. You give it the and if underscore output, and then we say 1. Okay, so there's something wrong. We are getting exception. So we are getting exception at this line. Okay, get opt qr. All right, -r1. Oh, sorry, r1. Okay, 1 or 2 was missing. So now if you look at then and if underscore output 1, we have this output. All right. Now we come to the final example, that is which I talked about earlier. So this is a very advanced example, and I do not expect you to understand this very well. So this is a plagiarism checker. It uses scikit-learn. So we have not yet studied scikit-learn. So it is kind of sort of machine learning you do. So there is something called TF-ID vectorizer, and there is something called cosine similarity. So we have three docs, doc 1, doc 2, and doc 3. And what we do is we find the keys of docs, that is doc 1, doc 2, doc 3, and we have values. So names are keys and texts are values. So first we create a TF-IDF vectorization. We create the object of TF-ID vectorizer with stop words. We use English. And then we have TF-IDF matrix. So we fit transform. We call fit transform on the text, that is this one. And then we perform cosine similarity on this matrix, that is the text matrix. And we get a similarity matrix. Once we have a similarity matrix, we go through the names, and then we run another loop and we move one position ahead of that. Essentially what we are doing is, for the names we are going through all combinations, and then we look at the similarity matrix score of ij, and then we find out what is the similarity matrix. If score is greater than or equal to threshold, then possibly paraphrase plagiarism. So if you look at this threshold is 0.65. So as you remember the similarity which we are talking about, if you look at this, where was that? Point 6, where was it mentioned? Point 6 of mentioned somewhere. Yeah, here. So it says that as a rule of thumb, if a ratio value of 0.6 means sequences are close matches. So here a value of 0.65 will mean it is plagiarized content. And then we have after that sequence level matching option. So in this case, you convert this into sentences and you go loop through sentences. And if length is less than 5, we don't do anything. And then we call get close matches. That is the same stuff, similar stuff like ratio. Okay. Once you do that, match is found or not. So that's what the sentence match using Difflib. So this is using Difflib and this is using scikit-learn. Okay, so there are two different things, and then we simply invoke that. Okay, so if you want to run this, you can run this using Python Difflib 1.5. No, this is this Difflib underscore example.py, not one. Difflib underscore example.py. Okay, we have to get the virtual env here in action because scikit-learn is installed in that. And there you go. So you see that the similarity matrix, similarity is 0.128. So it is safe, it is not plagiarized content. Okay. But in case of sequence level matching, it says matches are found. So the score of similarity matrix for each row that is found, you run the similarity matrix, it is looking at names, and similarity matrix is on the what you call TIDF matrix, that is text. So you got 3 rows of 3 values. The reason is you have 3 docs of 3 values and each having 3 sentences. This one has 2, so that is the combination of all those. So with this, we come to the end of this video, and in the next video of Python, we will move on to the next element. That is, we are going to cover text wrap. Do not worry if you don't understand this example. When we will study the scikit-learn, we will go through all this. Okay. For example, right now it's not showing me the cosine similarity. It says that it can't find the source code. So we'll see. I'll show you all the source code of this. So I'll end this video here, and in the next video we will study text wrap and we'll see what useful things we can do with text wrap. So thanks a lot for watching the video. I'll see you in the next one. Enjoy.